So we're going to look at flotation and the Archimedes principle. So before we get to understand everything, we need to know what does Archimedes principle state. So the Archimedes principle states that when a body is wholly or partially immersed in a fluid, it is going to experience an upthrust, which is the upward force pushing it upwards. So say I get to immerse an object here. When I immerse it partially or wholly, or it can be on a surface where one portion is in the fluid, one portion is not, it's going to experience an upward force in that direction, which we call the buoyance force or the upthrust. So buoyance is simply the tendency of a body to float or rise when submerged in a fluid. So when we get to immerse it in water like that, or in any fluid, it can be air or any liquid, there will be a certain volume of water that is going to pour in the beaker. So when we get to measure that weight of that water, that will give us the buoyance force, and the buoyance force is going to be equal to the weight of that water that has been displaced. So this is the weight of the fluid which is displaced. Now from here, buoyance force, where did this formula just come from? Should we just get to master it like that? So buoyance force, remember when you get to put something in a fluid, it will appear more lighter. You can think of something that is in water. As you get to pick it, it appears more lighter than something that is just on a surface. So buoyance force will be given by the force that something has minus the force that it appears to have, that is apparent force or the apparent weight. And we know that density is given by force over area. Therefore force is going to be given by, sorry, not density, but pressure is given by force over area. So force is going to be given by pressure times the area. Now pressure is given by density multiplied by gravity multiplied by height. So I get to substitute there. So this will give us buoyance force being equal to density times gravity times height. So this will be height 2 multiplied by area minus density times gravity times height 1 multiplied by the area. So the buoyance force is going to be equal to, we see everything is the same. What is only differing is the height. This is the height of the water level, or just the object that has been submerged. That is the height that has been submerged in the fluid. So I'll factorize out PGA and then remain with H2 minus H1. So this will give us buoyance force being equal to PGA, where there's H2 minus H1. Let me put X to remain difference in heights. And we know that density is mass over volume. Therefore mass is going to be density times volume. So where there is density times volume, what are we going to substitute? So here we have got first area times x, that is area times x. So we know that mass, before we talk about mass, for us to get volume we just get the area and then we multiply it by what? By the height. We can think of a cylinder. The area of a cylinder is area times the volume of a cylinder is area times the base area times the perpendicular height. So this is area multiplied by height. That is going to give us volume. So this will be PGV. Now density times volume, that gives us mass. So this buoyance force is going to be equal to mass times gravity. And we know what mass times gravity is. That is the weight. So this is where it comes from. Buoyance force is equal to the weight of the fluid displaced. So let's calculate these questions here. A 20 kg block of density 2700 kg per meter cubed is attached to a rope. What is the tension in the rope in a vacuum? So here we've got a rope and we've got an object there. So there is a tension force in that direction. So this thing has got a certain weight which is mg. So in this case, because there is no any other force, the weight is going to be equal to the tension. And weight, mass is 20, g is 9.8, so that is going to be equal to 196 newtons. So B, what to be tension in the air. So because you put it now in a fluid, there will be a buoyance force. There will be a force pushing it up. So you can see that now we have got two upward forces, tension plus buoyance force, and that is going to be equal to mg. I'll take buoyance force the other side. So tension is going to be mg minus buoyance force, which is given by density times gravity times volume. So let's calculate the volume of this object. We know that density is given by mass over volume. The density is given as 2700 of this object, and its mass is 20. What is its volume? So volume is going to be given by 20 divided by 2700, and volume is given going to be 0.0020 divided by 2700, 0.0074 meters cubed. So this will be mg, that gave us 196, minus density. Now this is the density of the fluid in which we've immersed, 1.29, multiplied by g, which is 9.8, multiplied by the volume, which is 0.0074. So this will give us 195.9 newton. So it is more the same, just like the one on top. So we see, because air has got a very small density, so to find the tension in water, tension is going to be mg minus density, gravity, volume. Mass times gravity is still 196. The density has changed. In here it is 1000 g is the same. The volume of the object is the same, 0.0074. So in this case we are taking the object is fully immersed. Okay. So 0.0074 multiplied by 9.8 multiplied by 1000. That answer we get, we're going to remove from 196. That is going to give us 123.4. That will be 41 newtons. So that is going to be it. So we see that the weight of the object appears to be even much less in water. An iceberg with a density of 917 kg per meters cubed floats in water with a density of 1000. So one portion is in the water and one portion is above the water. Now I want to find the fraction of the iceberg that is above the water and that fraction which is beneath the water. So we know that buoyance force is equal to the weight of the fluid displaced. And how do you find buoyance force? From what we did, it is the density of the fluid in which we've immersed multiplied by the volume of the solid and then multiplied by gravity. That's buoyance force, and that will be equal to the weight of the water or the fluid displaced. So that will be the density multiplied by the volume multiplied by gravity. So fluid displaced, this is the weight of the fluid displaced. Now in this case, the density, the volume that we are using to find the weight of the fluid that is displaced is of the object that we got to immerse in the water. The very portion that has been immersed in the water, the weight of the portion that is immersed in the water, because there's a certain force going up, is going to be equal to the weight of the fluid that is displaced. So this is of the object that we've immersed in the water. So G is the same, it gets to cancel out. So we're going to have the density of the fluid, volume of the solid is going to be equal to density of the object, volume of the object. So from here, let me divide both sides by density of the fluid, and let me divide both sides by the volume of the object. So this value here is going to cancel out, and this value here is going to cancel out. So what we are going to remain with is the volume of the solid over volume of the object is going to be equal to density of the object over the density of the fluid. Let me multiply both sides by the volume of the object. So the volume of the solid is going to be equal to the density of the object over the density of the fluid multiplied by the volume of the object. So this formula is very important here. Now this volume Vs, we are seeing volume of the solid, that is the volume that has been in water, that is immersed in the water. So volume of the solid immersed in the water is going to be the density of the object. What's the density of the object? That is 917, divided by the density of the fluid in which it is floating, that is 1000, multiplied by the volume of the object. Now the volume of object, you take the whole of this. So let's take it, we don't know the volume, so let's take it that it is 100%. So only a portion, this portion is the one which is floating in the water. So this is going to give us 917 divided by 1000, and then we're going to multiply that by 100. So this is telling us that 91.7% is what is in the water. Okay, 91.7 is above the water. Sorry, not above, but in the water. This is the portion that is in the water. So now what fraction is above the water surface? So the fraction above the water surface is just 100 minus 91.7, and that is just 8.3% above the water. So most of the portion here is immersed in the fluid. So that is how we get to find that. Let's consider this one. A block floats on a liquid of density 14,200 kg per meters cube. If 40% of the block is above the liquid, what is the density of the metal? Since we've already found the formula, let's get to use it. We are saying volume of the solid that is below the water divided by, okay, let me use the other one, density of the object over the density of the fluid, and then times the volume of the whole object. So a block floats on a liquid of density. So a liquid has got a density of, so we don't know the density of this object, but a liquid, the fluid has got a density of 1400, 14,200. Okay, like that. So want 40% of the block is above the liquid. This volume we are using here is the volume of the object that is below the liquid. So what volume is below the liquid if 40% is above the liquid? That's 60%. So 60% is above the liquid, and then times the volume, the total volume of the object, that is 100%. So what will be the density then? So this zero can, okay, we can first leave it like that. So here we're going to have 60 is equal to, these two zeros can cancel with these two zeros. That will be density of the object divided by 142. So the density of the object is going to be equal to 142 multiplied by 60. That is 8,520 kg per meter cubed. So this is the density of the object when 40% is above the liquid. Let's consider this one. A cube of length 10 meters is suspended between a oil which is having a density of 800 kg per meters cube and water having a density of 1000 kg per meter cubed. So what will be the density of this object? How are we able to determine the density of the object? So from the formula that we wrote, we saw that volume of the solid divided by the volume of the whole object is going to be equal to density of the object divided by the density of the fluid. So from here, let's make density of the object is subject to the formula. So the density of the object, we are going to multiply these two values. That is going to be equal to volume of the solid multiplied by the density of the fluid, and then divided by the volume of the object. I can also write this as the density of the object is equal to density of the fluid multiplied by the volume of the solid over volume of the object, like that. Now because here it is suspended between two fluids, So the density of the object is going to be the density of the fluid multiplied by the volume of the solid over volume of the object, plus again the density of the other fluid multiplied by the volume of the solid over the volume of the object. Now we don't know the volumes here. All we know are the heights. How do you find volume? So density of the object then is going to be equal to the density of the fluid. Let me call it P1 because they are looking all the same. So volume is given by area multiplied by height. The area of the object multiplied by the height of the object. Let me call it H1 over the area of the object multiplied by the height. This now is the total height since this was the total volume of the object. And then plus pressure of the density of the object. Now let me call it 2 density of the fluid. That will be equal to area of the fluid multiplied by the height of the fluid 2 divided by the area of the fluid multiplied by the total height of the fluid now. So this will give us the density of the object being equal to density of the fluid. The area will cancel out, so that will be H1 over H, and then plus P2. Also here the heights will cancel, H2 over H. So this is going to become the formula in this case. Let's get to work it out. The density of the object is going to be equal to, let's get what's on top. Well, water's got a higher density, so it is going to be beneath. So water is down here, and then the oil is the one which gets to float. What's the density of the oil we put there? The density of the oil, that is 800. Now, what is the height of the object in oil? That is 6. And what's its total height? Its total height is 10. And then plus the density of the water, that is 1000. What portion is in the water? That is 4 centimeters. And then divided by the height of the object, that is 10. So that is going to give us, this 0 can cancel out with this 0. 8 times 6, that is 480. This also 0 can cancel with that 0, so 100 times 4, that is 400. So the density of the object is going to be 480 plus 400. That is going to be 880 kg per meter cubed. That is the density of the object. Let's consider another question here. An iron cube having a density of 7700 kg per meter cubed has sides of 6 millimeters. So this is a cube, all the sides are the same. So this one is lying in equilibrium between a layer of mercury of a density of 13,600 kg per meter cubed and water, which is having a density of 1000 kg per meter cubed. So find the length of each position in each liquid. So if this, so we have got two lengths here. We have got this one and this one, which is in the mercury. Mercury has got a density of 13,600, and then water has got a density of 1000. So which one is going to float over the other? So mercury is going to be down 13,600. Water is going to be above 1000 because its density is smaller. So if this distance in water is called x, and this object has got side lengths of 60 millimeters, let's convert first to meters. 60 millimeters, we are going to multiply. We have got a millimeter goes down, we want a meter on top. In 1 meter we have got 1000 millimeters. So that is going to give us 1 0 is going to cancel. That is going to be 0.06 meters. So the whole of this object is having a side length each of 0.06. So if the portion which is in water is x, then the portion which is in the mercury is going to be 0.06 minus x. Okay, 0.06 minus x. So let me just write here what is in water is x, what is in the mercury is 0.06 minus x. Using the same formula that you've seen in the previous question, density of the object is equal to density of the first fluid and then height 1 over the total height plus the density of the second fluid, then height 2 over the total height. Now the density of the object, iron cube with a density of 7,700, and that is going to be equal to the density. Let's start with the density of what's on top, that is water, 1000. The height in water is x, the total height is 0.06, then plus the density of the mercury, that is 13,600. The height in mercury is 0.06 minus x over the total height, which is 0.06. So we have got 7,700 being equal to 1000x divided by 0.06 plus. Okay, let me just get to divide direct. I'm going to say 0.06 into 1000. 1000 divided by 0.06. That is going to give us 16666.67 and then x. Okay, and then plus, we'll also say this value into there. So 13,600 divided by 0.06. It is given me 13,599.94, and then we have got 0.06 minus x. So that is going to give us 7,700 being equal to 16666.67x, and then we'll distribute this. So this value we have 13,599.94 multiplied by 0.06. So let me just get to see that. It will come and give us again this value. We can also think of it in this way. We can split these two terms which are here. So what we are going to have is 13,600 multiplied by 0.06 over 0.06 minus x over 0.06. 0.06 over 0.06 is a 1, and 1 times this portion will be itself. So that will be positive 13,600, and then minus, now we get this one into there. 13,600 divided by 0.06, that is the same value that we got to find. So let's hope I didn't just punch it wrongly on my calculator. It seems so I had punched it wrongly, because 13,600 divided by 0.06 is not giving me this value, so this was an error in punching. So that is giving 226666.67. So if we get to multiply this and this, we are going to get back the 13,600. Oh, that one I've already written there. So, and then we are multiplying with x. This term we are multiplying now with the x. That would be negative 22666.67x. Now we're going to take all the terms that have got x to one side and those without x to the other side. So here this one has got x, this one has got x. So I'm going to subtract them. So 16666.67 minus 2266666.67, that is going to give us a negative 209,999.967x. And then we'll take this term this side to become negative. So it will be 7700 minus 13600. That is going to be negative 5900. So to remain with x, we divide both sides by this term. So x therefore is going to be equal to 5900 divided by 209999. Those are 4 9s.9967. That is going to give us 0.028095. This answer is in meters, so we can convert it to millimeters to see how rational it is. So get to multiply. A meter will go down, a millimeter on top. In 1 meter we've got 1,000 millimeters, or times 1,000. So x is going to be equal to 28.1 millimeters. So what does this tell us? The portion that is in water is represented by x, that is 28.1 millimeters, and then the portion that is in the mercury is going to be 60 millimeters minus 28.1 millimeters, that is going to be 31.9 millimeters. And that marks the end of this video. Thank you so much for watching. Stay blessed.